Let's check out some standard form notes. First thing is, there's our buddy. There's our guy's slope-intercept form. We love him because pretty much he's the easiest one to work with. We all want to be his buddy. And then here's point-slope form, which he's not bad. You know, if we have to, we'll hang out with him. And then I know I'm kind of setting up standard form for some hate, but standard form, generally, people kind of freak out about him because there's 1, 2, 3, 4, 5 variables. And if you're like, but wait, aren't there like 1, 2, 3, 4 here? And aren't there like 1, 2, 3, 4, 5 there? And it's like, well, yeah, but for some reason, people, they get this one that y equals, you need the slope, right? And you need the y-intercept, and those are pretty, not bad to find. And then this guy has similar stuff in that he just has a point, and hang on, so there's the slope, and then how about the point? His points are here and here. So basically both of these guys have this overlap where they have the slope and just a point, right? Even though this one has a specific point, right? But over here, this is like, well, what are these things? Well, first of all, A needs to be positive and a whole number. Like, this is almost just like rules. Hey, listen, in order for you to qualify it for standard form, this is like rule number 1. And then rule number 2 is that B and C should also be whole numbers. And so we actually kind of got off on a little rabbit trail real fast in class today, and that we said, well, okay, well, what if A is not positive? Okay, well, let's run through some examples. What if you had like negative x plus 2y equals 3? Okay, well, this is close to standard form because, look, it's ax, by, c. Ax, by, c. A just happens to be negative 1, right? So what we're going to do is we would multiply the whole thing, both sides, by negative 1. And so what you'd end up getting is x minus 2y equals negative 3. And now we're happy. That's in standard form. That's standard form. And then they're like, okay, well, now what if, obviously the x is not the a right here. What if that's not 1? What if it's a fraction? And then I said, okay, 1/2 plus 1/4 y equals 1/8. Let's multiply both sides by a number that will get rid of that fraction and that fraction, and the answer is 8. So when we multiply by 8, this becomes 4x, and this becomes 2y, and then this side is just 1. And oh, look, now it's nice and pretty standard form. So that part, I think most everyone today was really on board with really pretty quickly. And then the only other thing about this was just it needs to fit this so that it like is the style we're looking for. And now you kind of see like there was no mention of style for these two. So what the heck? What's with you, standard form? And then the other thing is with these, you were given exactly what to look for. And if you're like, what do you mean you were given exactly what to look for? You started with the y-intercept and then you use the slope. With this, you used your point and then you use the slope. With this guy, there's no slope to look at. There's not even a point really to look at. So slide over here and let's actually graph one of these. So here are your methods for graphing. Number 1 is you can rearrange to y equals mx plus b. And I got to tell you, there's a lot of people who that's what they're going to do. And number 2 is something I call the slap. And then number 3 is a table. Okay, so let's do the rearrange real quick. So basically, what's nice about this is one of the rules is if y is by itself, then dude, you are in slope-intercept form. Okay, so what we're going to do is subtract 2x, and we get y equals negative 2x plus 4. And we can graph that real easy because it's in slope-intercept form, meaning you start with the y-intercept of 4, And if you're like, well, where is that? It's right there, right? And then next is the slope of -2. So what we would do is we would go down 2 over 1, down 2 over 1. And there's the graph, right? That is the graph of this equation. So if you're wondering, well, then why the heck do we need, or why would we learn the the standard form? I almost said slope-intercept form because that's what that is. Well, I'm glad you asked. Let's erase all this. If I can, here we go. Let's erase it. And now do that. So what you can do, like I said, rearrange it. Check, we did that. Let's talk about the slap in the table. So what I call the slap is really just out of trying to come up with something goofy for you to remember. But basically, the slap gives you the x-intercept and gives you the y-intercept. You're familiar with this one. We like the y-intercept, so let's go after him first. The y-intercept is when x is 0. So if you were going to slap this equation, since I actually have a hand, actually I guess it's more of a pointer. Do I have a hand? Here's an owl. Okay, this owl is going to slap the x, whoosh, and if it slaps it, then it's gone. Okay, you've destroyed it. What do you now see? I see y equals 4. The y-intercept is 4. We write it with some coordinates of x is 0, y is 4. There it is. That's not that bad, right? Okay, so now let's erase our slap and let's find the x-intercept. Well, when you find the x-intercept, y is equal to 0. So, Mr. Owl, can you slap the y? And what happens is now this is gone. And you might think, okay, well, that looks a little uglier. Well, really, all you have is 2x equals 4. Divide by 2 on each side, and you get that the x-intercept is 2, right? X is 2 when you solve that right there. So we now, and we could also write this in a coordinate if we wanted to. X is 2, y is 0. When x is 2, y is 0. And then check this out. We have our line. In fact, we have the exact line that we had earlier, right? Going through that. In fact, we could now describe the slope if we wanted to. It is rise 1, 2, 3, 4, run -2, right? Rise 4, run -2. That was a slope of -2, which, by the way, if we were to solve this and put it in slope-intercept form, don't you see that, where'd my pointer go there, that my the 2 in front of here would be over here, and it would be -2, and blah, blah, blah. So, boom. This right here, x and y intercepts, is why we do this. And if you think, well, why would I ever want that? Maybe that's all you're interested in. Maybe this is like an equation for profit or something. So, at time is 0, you are, this is not, you don't actually make money right here. You're doing 0 work. But then after 2 hours of work, now you're making 0 money. So your goal is to make, do the job within this window right here. And you have a sliding scale of how much money you make. And this isn't super realistic for money, but you get kind of the idea, right? By the way, notice I didn't do the zit table, but here is a table, which what you would do is you would say, hey, you know what, let's plug in 0 for x, ba-boom, and that would be 2 times 0 plus y equals 4. Well, anything times 0 is 0, and we don't really write that down, so y equals 4. Right there it is, right? There's your table. Anything at all. If I asked you to graph this equation right here, y equals 3x cubed minus 7x squared plus 1 over x, you could graph this with a table. You just go, okay, what happens when x is 0? What happens when x is 2? And then you just plug it in, and solve it. Okay? Okay. So now there's just some more examples. And I'm going to do the slap, or, the x-intercept and the y-intercept on most of these because that's kind of the challenge, right? Because you could solve it for y. In fact, maybe I'll write that at the end. But if you're watching this, I don't know. Actually, I don't know who's really going to be watching this, but I'm making it anyway. So there we go. Let's move on. The x-intercept, that's when y equals 0. So slap, gone. I have 3x equals negative 15. X must equal negative 5. So right there, I just got that point. And then let's erase our slab. Let's do y-intercept. That's when x equals 0. So negative 5 equals negative 15. That's when y equals 3. Right there. And now there's our graph. Pretty easy if you ask me. Again, if we had solved it for y, well, let's do that like down here, shall we? 3x minus 5y equals negative 15. Well, so subtract 3x and then divide by negative 5. So that one wasn't really that bad. Hang on, is that even right? Did I write this down correctly? This is supposed to be a 3, so negative 3. So hold up. This would actually be 3/5 x plus 3. Okay, little on the ugly side, but not that bad. And check it out. I mean, there's the y-intercept of 3. And if you were to do 3/5, you could go down 3, back 5. Negative is positive, and it would still work, right? But again, maybe you want the x and y-intercept, just maybe. And so here's a little exercise of like, hey, well, what using the table could you do this? So what are these? This one is the y-intercept. How do I know? Because x is 0. So when x is 0, this is negative 4, okay? Oh, and is this a different equation? Yes, this is a different equation. So, sorry, I guess I kind of skipped over one. We wrote these previously, and so yeah, this is a different one. I was, in my mind, had something else going on. Anyway, moving on. So, y-intercept, negative 4. X-intercept, well, then y is 0. The x-intercept, if y is 0, there's a slap. This is negative 3 right there. There's our graph. Like that, yeah? Just another couple examples, and then we'll do a quote-unquote real-life example. So let's see, for the y-intercept, and now, again, if I were doing this in person, if I was on if you were in front of me, you would see my finger covering this up, and I would go, oh, look, negative 6y equals 30, y is negative 5. And what I like about this is I can do this in my head. Don't you love doing math in your head? I mean, that's our preference. We hate to write stuff down. But anyway, the x-intercept was when y equals 0. So the x-intercept is 6. Boom. There's the graph. One more. X-intercept is is when x equals negative 1. Y-intercept. Y is negative 2. Boom. That was a really ugly line, but I think you get the idea. There we go. So now, sliding over here, just a reminder. We know that like a horizontal line is going to be hoy. Because we talked about this once. Horizontal, the slope is 0, and it's y equals something. So in particular, it's y equals the b, and that checks out from when we did this, right? And then check this out over here. I've rarely talked about this, but this is an x equals a line. This is vux. V is for vertical, U is for undefined slope, and it's an x equals type thing. And I rarely ever talk about A being the letter we use for that. Not to be confused with AX plus BY equals C, right? Because we can't just look at that number and go, x-intercept, right? Because it is here, right? Lowercase b, capital B. Y'all know the difference. Anyway, what are the equations of these lines? Well, let's see. There's hoy and vux. This is horizontal, so this is y equals negative 2. This is vertical, so we have hoy. Actually, I really like to say vux and hoy, even though I didn't do it either way over here. Vux, it's vertical, so that's x equals 3. Okay, and then notice the slope is undefined because it's vertical, yeah? All right, now the real world problem, which I kind of sped through in class, but here's the idea. You're planning an award banquet and need to rent tables to seat 180 people. Well, maybe you're writing this equation. I want a total of 180. This is a word problem strategy. You have a total, you write equals that total, yeah? Yeah. There are 2 table sizes available. Small tables seat 6 people, so let's call it 6x. And then large tables seat 10 people plus 10y. You don't know how many of these tables you're going to want. Same thing with this one. This is now a model for this situation. It doesn't seem like there was a whole lot of thought that went into it, right? It just seemed like, man, we wrote that really fast. And again, that is the beauty of standard form a little bit, right? And we could find this information really fast and this information really fast because that's the y-intercept. This is the x-intercept, right? And so they kind of say, well, hey, could you give us like maybe a few solutions? And so, yeah, here's the idea. You could have 18 big tables. You could have 30 small tables. But you could have some mixture in between. Obviously, we can't have fractions of tables, so this might be a little frustrating because if you zoom in, not an intersection, this one might be. Nope, maybe. Nope. Okay, so maybe there's just 2 intersections. And what we could do is say, okay, well, maybe, when x equals 10 and maybe when x equals 20, you know what I mean? And in those situations, we could then work it out, right? One last thing I'll say is when it comes to these things, they use some vocabulary, a coefficient. Wow, let's try that again. Coefficient. There we go. That's the number in front of the variable. 3 is our coefficient. This whole thing is called a term. Okay? So like when we have ax plus by equals c, that's 3 terms. And a is 1 coefficient, and b is 1 coefficient, right? And for example, in our problem up here, this was table type 1, this was table type 2. Anyway, I think you get the idea when it comes to this. And then just a reminder, yeah, the x and y intercepts are great, but also sometimes we just should do that because it's in slope-intercept form, and then we can graph it. And that's standard form. Let me know if you got any questions. Bye.